This topic is about solving equations with unknowns in the powers and within the logarithmic function. We also need to be able to solve worded problems involving logarithms. Okay, so let's go through lots of examples on how to solve equations. So first one, solve 4 to the power of 3x plus 1 is equal to 7 to the power of x plus 2. Now you have a choice here. You can either take log base 4 on both sides or log base 7. I will take log base 4 on both sides. So when I do that, I get log base 4 of 4 to the power of 3x plus 1 is equal to log base 4. So whichever log you take the same thing on both sides, 7 to the power of x plus 2. Now the laws of logs tells me I can take the index down. So it's the same thing as 3x plus 1 times log base 4 of 4 and x plus 2 times log base 4 of 7. Now I know log base 4 of 4 is the same thing as 4 to the power of something gives me 4, which is equal to 1. So I can rewrite that as 3x plus 1 is just left over on the left-hand side, because 3x plus 1 times 1 is just 3x plus 1, is equal to, if I expand out the right-hand side, I get x log base 4, 7 plus 2 log base 4, 7. Now I have a combination of x and constants, so I would want to take all the x's to one side and all the constants to the other side. So if I move x log 4, 7 to the left-hand side, I get 3x take away x log base 4, 7. And on the right-hand side, I get 2 log base 4, 7. The plus 1 goes to the right-hand side, so it becomes minus 1. Okay, I need to factorize the left-hand side, so I get x times 3 minus log base 4, 7 is equal to 2 log base 4, 7, take away 1. The last thing I need to do is just do a division. So x must be equal to 2 log base 4, 7, take away 1, all over 3 minus log base 4, 7. That is an exact answer. So we haven't been asked to round, so I would leave it as an exact answer. Next question. So this one, it says solve to 3 significant figures. So once we've worked it out, we'll use a calculator to round to 3 significant figures. Okay, so again, we have a choice. We've got 5 to the power of something and 3 to the power of something. So you can either apply log base 5 to the both sides or log base 3. And I will be applying log base 5 to both sides. So I get log base 5 of 5 to the power of 2x is equal to log base 5, 3 to the power of 2 minus x. Okay, now the laws of indices tells me I can take the power down, so it becomes 2x times log base 5 of 5 and 2 minus x, make sure you put a bracket around it or else you're going to get confused later on, log base 5 of 3. Now I know log base 5 of 5 is the same thing as 5 to the power of something is 5, which is just 1. So 2x times 1 gives me 2x. So I've got 2x on the left-hand side. If I expand the bracket on the right-hand side, I get 2 log base 5, 3, take away x log base 5, 3. Okay, I need to collect all the x's on the left-hand side. So I get 2x plus x log base 5, 3 is equal to 2 log base 5, 3. If I factorize that x out on the left-hand side, I get x times 2 plus log base 5, 3 is equal to 2 log base 5, 3. X would be equal to then 2 log base 5, 3 all over 2 plus log base 5, 3. All I need to do now is put this into the calculator. When I put this into the calculator, I get this number 0.50899127, blah, blah, blah. If I round it to 3 significant figures, x is roughly 0.509. And that would be the end because we're asked to round to 3 significant figures. Okay, different question now. Find the coordinates of the point of intersection of y is equal to 3 to the power of 2x plus 1 and y is equal to 4 to the power of x plus 1. So again, because we have two equations, both have y as the subject of the formula, we can just equate the two equations. So we have to solve basically 3 to the power of 2x plus 1 is equal to 4 to the power of x plus 1. So again, we have a choice here. So I'm going to apply log base 3 to both sides. So log base 3, 3 to the power of 2x plus 1 is equal to log base 3, 4 to the power of x plus 1. Okay. If I apply the laws of indices, it's the same thing as 2x plus 1 times log base 3, 3, and x plus 1 times log base 3 of 4. Now, the whole point, you realize you always simplify, because you take log base 3 or log base 4, something will reduce down to 1, which is obviously log base 3, 3. So what we end up getting on the left-hand side is 2x plus 1 is equal to, if you expand the bracket on the right-hand side, I get x log base 3, 4 plus log base 3, 4. I integrate all the x's on the left-hand side and all the constant in the right-hand side. So I get 2x. If I move the x log 3, 4 to the left-hand side, I get minus x log base 3, 4. On the right-hand side, I have log base 3, 4. The plus 1 becomes minus 1 when I move it to the right-hand side. Factorize the x out. So I get x times 2 minus log base 3, 4 is equal to log base 3, 4 take away 1. X is equal to, all you need to do is divide it. So you get log base 3, 4 minus 1 over 2 minus log base 3, 4. Now if you put this into your calculator, you get 0.354755, going on forever. Which, if you round, you get x is equal to 0.355. So that is your value of x. Okay, now to find y, you can either substitute into x, sorry, equation 1 or equation 2. I'm going to just substitute into equation 2. Y is equal to, sorry, equation 1, 3 to the power of 2x plus 1. So y is equal to 3 to the power of 2 times 0.3547. So use the non-rounded version to get your answer, which gives us 6.541000. So y is approximately 6.541. Okay, so the point of intersection. Point of intersection is 0.355, 6.541. Okay, next question. Find the smallest integer satisfying 2 to the power of n is greater than 100 to the power of 643. Okay, so we're trying to solve this. Okay, so here I have a choice. Either take log base 2 or log base 100. Now, I feel like taking log base 100 in this case would make my life easier because it's the bigger base, as in the base is bigger, the 100 is bigger. So if I don't use that one, it might get my calculator might not calculate it. So I will take log base 100 on both sides for this one. So log base 100 of 2 to the power of n is greater than log base 100 to the power of 643. So remember, you always have a choice. So use one which you think will make your life easier. Here, which gives me n times log base 100 of 2 greater than, remember these two cancel out, log base 100 is the inverse of 100 to the power of, so greater than 643 I end up getting. So n must be, therefore, n must be greater than 643 over log base 100 2. If I put this into my calculator, I get n is greater than 4271.99 and going on forever. So if n has to be greater than this number, then n, the smallest n can be, is equal to 4272. Okay, next one. Given the simultaneous equations 2 to the power of x is equal to 3 to the power of y, and y plus x is equal to 1, show that x is equal to solve. Okay, so I know if y plus x is equal to 1, then y is equal to 1 minus x. So I've arranged to make y the subject of the formula. So that means in the equation 2x is equal to 3 to the power of y, I can instead write 2 to the power of x is equal to 3 to the power of 1 minus x. Okay, I will take log, because the answer, what I'm aiming for, has log base 10, I will take log base 10 on both sides. So log base 10 of 2 to the power of x is equal to log base 10, 3 to the power of 1 minus x. Okay, applying the laws of indices, I get x log 10, 2 is equal to 1 minus x times log base 10, 3. If I expand the right hand side, I get log base 10, 3, take away x log base 10, 3. Okay, I need to collect the x's on one side and the constants on the other. So if I move minus x log 10, 3 to the left hand side, I get x log 10 base 10, 2 plus x log base 10, 3 is equal to log base 10, 3. Factorize that x out, so I get log base 10, 2 plus log base 10, 3 is equal to log base 10, 3. X is equal to log base 10, 3. Because it's multiplying, we do the opposite, which is dividing. So I get log base 10, 2 log base 10, 2 plus log base 10, 3 in the denominator. Now I know when the rules of logs tells me when I have logs of the same base adding together, then it's the same thing as multiplying, putting them together by multiplying the input. So it's the same thing as log base 10, 3 over log base 10, 2 times 3, which is 6. And that is what we were aiming for. Now, a common mistake is some people might reduce that to log base 10, 3 divided by 6 is the half. But remember, it's when it's subtraction. If it was log base 10, 3, take away log base 10, 6, it will be log base 10, 12. It's not division. Okay, so don't do that mistake. Okay. Solve 10 to the power of 2 minus x. 2 minus 2x is equal to 2 times 10 to the minus x to 3 decimal places. So I've got 10 to the power of 2 minus 2x is equal to 2 times 10 to the minus x. Now 10 to the minus x is the same thing as 2 over 10 to the power of x, because if it's a negative, it means it's just in the denominator. Okay, so if I want to get rid of 10 dividing by 10 to the power of x, I take it to the left-hand side, it becomes 10 to the power of 2 minus 2x times 10 to the power of x is equal to 2. Okay, now by the rules of indices, I know that's the same thing as 10 to the power of 2 minus 2x plus x, which is equal to 2. Which gives me 10 to the power of 2 minus 2x plus x gives me minus x. So it's 2 minus x, which is equal to 2. Now, because I put unknown in the power, I need to take log base 10 because it's 10 to the power of something. So log base 10 of 10 to the power of 2 minus x is equal to log base 10 of 2. These cancel out, so I've got 2 minus x is equal to log base 10 of 2, which means 2 is equal to log base 10, 2 plus x, which means x must be equal to 2 minus log base 10 of 2. I put that into a calculator, I get x is equal to 1.6989 blah blah blah, which is roughly, to 3 decimal places, 1.70. Okay, now sometimes you have unknowns to solve with log functions, within log functions. So here we need to solve 3 plus 2 log base 2x is equal to log base 2 10x minus 3. Now we can rewrite this as obviously 3 plus log base 2x squared, because the 2 comes up to be the power, which is equal to log base 2 of 10x minus 3. Now when we're applying logs, don't forget the input of the log function always has to be greater than 0. So we've got the case where x squared has to be greater than 0, which is always the case. So that's true for everything. And we've got 10x minus 3 has to be greater than 0, which means 10x must be greater than 3, which means x must be greater than 3 over 10. Okay, so when we find a solution, we have to make sure they're greater than 3 over 10 in order to work in this equation. Okay, now in this case, we need to get rid of the log somehow. So we need to collect all the logs on the same side. So I will leave the 3 on the left-hand side. When I move the log 2 base 2x squared to the other side, I get subtract log base 2x squared. Now, when you're subtracting logs with the same base, the same thing as dividing. So log base 2, you can combine them and write it as a division. So 10x minus 3 over x squared. Okay, now I need to get rid of log base 2, so I apply 2 to the power to both sides. So 2 to the power of 3 is equal to 2 to the power of log base 2 of 10x minus 3 over x squared, which means these two cancel out. So 2 cubed is 8. 8 is equal to 10x minus 3 over x squared, which means 8x squared is equal to 10x minus 3. Which means 8x squared minus 10x plus 3 is equal to 0. Now, if I factorize this using trial and error, I get 4x here, 2x here, and 1a plus 1 here, and then minus 3 here. Okay, I made a mistake here, sorry. Let's try again. That did not work out. So I want a minus 3 here and a minus 1. So that would give me the positive 3 for the constant term. Minus 4x minus 6x gives me minus 10x. So that does work out. So x would be equal to 3/4 in this case. Or x will be equal to 1/2. Now both these numbers are greater than 3 over 10. So these are both solutions. So solutions are x is equal to 3/4 and x is equal to 1/2. Okay, next question. 2 log base 4x minus log base 4 7x minus 3 is equal to minus 1/2 to 3 significant figures. So in this case, x has to be, the conditions are that x has to be greater than 0 and also 7x minus 3. So remember, the input for the log function needs to be also greater than 0. So which means x must be greater than 3 over 7. So it has to satisfy this. Let me just not highlight that because it looks like the solution. Okay, so we apply the laws on logs first. So we've got 2 log base 4x minus the log base 4 of 7x minus 3 is equal to minus 1/2. So first thing is, if we apply the laws of logs to the first term, you get log base 4x squared minus log base 4 of 7x minus 3 is equal to minus 1/2. Because it's subtracting, again, applying the laws of logs, I get x squared divided by, I can combine the two logs to get x squared over 7x minus 3 is equal to minus 1/2. Now that we've got in terms of log base 4, the unknowns in terms of log base 4, I can do 4 to the power of on both sides. So 4 to the power of log base 4 x squared over 7x minus 3 is equal to 4 to the power of minus 1/2. Now we get x squared over 7x minus 3 on the left-hand side. And on the right-hand side, 4 to the power of minus 1/2 is 1 over square root of 4, which is just half. Okay, if we cross multiply, I get x squared times 2 on the left-hand side. So it's 2x squared is equal to 7x minus 3, which means 2x squared minus 7x plus 3 is equal to 0. If I factorize it, I get 2x and x. I need a minus 3 here and a minus 1 there, which means x is equal to 1/2 and x is equal to 3. Both of them are greater than 3 over 7, so both of them are solutions. Okay, next one. Show that log base 3, 3x minus 1 minus 2 log base 3x is equal to 1 has no real roots. Okay, so first thing I need to do is apply the laws of logs to the second term in the left-hand side. So it's going to be log base 3 x squared is equal to 1. Now I've got the first two terms. The two terms in the left-hand side in terms of log base 3. I can combine the two terms as 3x minus 1 over x squared, because they're separated by a subtraction sign, is equal to 1. Okay, I need to do 3 to the power of to get rid of the log base 3, as it's the inverse of log base 3. So I get 3x minus 1 over x squared is equal to 3 to the power of 1, which is just 3. 3x minus 1 is equal to 3x squared. If I rearrange to make the left-hand side equal to 0, I get 3x squared minus 3x plus 1 is equal to 0. Now, obviously, I need to work out the discriminant now, because if it has no real roots, the discriminant must be less than 0. So a is equal to 1 in this case, b is equal to minus, a is equal to 1. Don't know where I got that from. A is equal to 3, b is equal to minus 3, and c is equal to 1, which implies discriminant is equal to b squared minus 4ac is equal to minus 3 squared minus 4 times 3 times 1, which is 9 minus 12, which is equal to negative 3, which is less than 0. Since discriminant is less than 0, the equation has no real roots. Given that log base 3x is equal to k, find in terms of k, a is log base 3 of x squared. Okay, using the laws of logs, I can rewrite that as 2 log base 3x. But log base 3 of x is just equal to k. So it's just 2 times k, which is equal to 2k. B, log base 3 of 9x. The same thing as log base 3 of 9 times x, which can be separated into log base 3 9 plus log base 3 of x. Log base 3 9 is just 3 to the power of something is 9, which is 2. Log base 3x, again, using what we know, is equal to k. So it's just 2 plus k. C is log base 3 x to the power of a half over 3. That's the same thing as log base 3 of x to the power of a half minus log base 3 of 3. That is the same thing as half times log base 3x. Log base 3 of 3 is just 3 to the power of something gives you 3, which is just 1. Log base 3x is just k, so it's just half k take away 1. Hence solve log base 3x squared plus log base 3x to the power of half over 3 minus log base 3 9x is equal to 0. So log base 3x squared is just 2k. So 2k plus log base 3x to the power of half over 3 is just half k minus 1 minus log base 3 9x is just 2 plus k. So we've just worked all these things out, is equal to 0. So that's what we're trying to solve. So 2k plus half k minus k, so it's 2.5k minus k gives me 1.5k. So 3 over 2k minus 1 minus 2 gives me minus 3 is equal to 0, which means 3 over 2k is equal to 3, which means 3k is equal to 6, which means k is equal to 2. If we're trying to solve this equation, which means we need to find solve for x. So what we do know is log base 3 of x is equal to 2, because it's equal to k, which implies 3 to the power of log base 3 of x is equal to 3 to the power of, that does not like 3 to the power of, 3 to the power of 2, which means x is equal to 3 squared, which is just 9. So now we've solved for mx. Julia starts a new job on a salary of 15,000 per annum. She's promised that her salary will increase by 4.5%. Increase by 4.5% means 100 plus 4.5%, which is 104.5%, which is equal to 1.045 as a multiplier. So increase by 4.5% at the end of each year. If she stays in the same job, how long will it take before she earns more than double her salary? More than double her salary is 30,000. Okay, so that means the salary that she started off with is 15,000 times by the multiplier, which is 1.045 to the power of n, has to be greater than double her salary, which is 30,000. So I just solve this equation. Okay, if I divide by 15,000, I get 1.05045 to the power of n is greater than 30,000 divided by 15,000, which is just 2. So 1.05045 to the power of n is greater than 2. I've got n as my unknown is 1.045 to the power of n, so I need to take log base 10, log base 1.045 to the power of n, which is greater than a log of 1.045 of 2. Okay, these two things cancel out. So n must be greater than log 1.045 2. Put that into a calculator, n must be greater than 15.7473. So n must be equal to, if it's greater than 15.7, it must be equal to 16. Last thing I want to say is a common mistake, which is a word of warning. Okay, I see this mistake a lot with students. Can you make sure you don't make this mistake? So if I have an equation like this, log base 2 of 2x plus 2 times log base 2 of x minus 2 is equal to 0. Okay, first, most students correctly apply the laws of logs to the second term. So you get plus log base 2x squared, take away 2 is equal to 0. So there are no errors at this point. But this is where they make the mistake. They think, okay, we've got log base 2 here in 2 terms. So what I'm going to do is I'm going to apply 2 to the power of to everything. So 2 to the power of all this, log base 2x plus log base 2x squared minus 2 is equal to 2 to the power of 0. But where they make the mistake is they think this is the same thing as 2 log base 2x plus 2 log base 2x squared minus 2 to the power of 2 is equal to 2 to the power of 0. So what they've done is they've separated each term out, and that is an error. You can't do this, okay? So that would, obviously, if they continued on, they'd get 2x plus x squared minus 4 is equal to 1, and then they'd continue, obviously, with that mistake and follow it forward. So don't make this mistake. It's not the same thing. What you need to do instead is collect the logs to one side, everything with logs to one side, logs with the same base, and obviously all the other constants to the other side before you take 2 to the power of. So you need to collect all the logs together somehow and then get rid of it. So please don't make this mistake where you do 2 to the power of a string of terms and then you separate these string of terms out, because that would be an error. So don't make this mistake.